In this video, we'll be doing a constructing a velocity versus time graph given a distance versus time graph. This is a follow-up to our graphing and motion compared video. Now, as you can see here, we got this graph here. It's a distance and it's versus a time. And we're going to take this and turn it into a velocity versus time graph. Now, as we said in the previous video, that as distance moves to velocity, and as velocity moves to there, as you move down, it equals the slope. As you move up, it equals the area under the curve. Today we're just going from distance to velocity, so we're going to be looking at the slope of everything. Another way we can look at it is this. Curves will always go to diagonals. Diagonals will go to flat lines. Flat lines will always go to being a flat line along the x-axis. So with this knowledge, we can actually go through this. Now there's a couple steps that we have to do before this. The first step is to divide up our graph here into usable chunks. So the first one I'm going to do is I'm going to look for anywhere where there's a break in its type of line. So for instance, this is nice and linear, then it curves, linear, and then another positive line. So I'm going to break it right here. And it looks like it's also going to start becoming linear again here. And then we have this segment here up all the way up to, we'll say there, just because it's a nice, crosses that nice point. Notice that these numbers are not in units of ones, but these are in units of fives, but the time is in units of ones. The next step is to calculate our velocities of everything that is in our straight. We have velocity of A, B, and C. To calculate the velocities, it is just get the slope. If we have the distance graph, we get the slope to get the velocity. So A, we look at here, we have our final, which is at our final time here is at -5 to 35, which gives us a difference of 40. So its rise is -40. It's going down 40 units, and then it goes over 1, 2, 3 units. That gives us a total of 13.3. B, well, that's this segment. We're going to skip this curvy section here in just a minute and go to this section. B is a fall of 10. And it goes over in 6. It goes over in 6. So that is a 1.6 negative. These are all negatives. But then you have part C, which is a positive one. And that goes up 45, a rise of 45, over a period of 5 seconds. And that gives us a time or a velocity of 9. Now these numbers are important because that's going to determine what numbers we're going to use here. I noticed that 13, 1, -13, positive 1, -1, and 9. So I want something to branch those. So I'm thinking of going in units of 3. So 3, 6, 9, 12, and so forth. Let me finish that up here in just a second. Now that I've marked out the y-axis with my numbers, locating my lowest number to my highest number, I got a graph that looks like this, ranging from positive 18 to negative 18. Now we can change these lines here. Now what we need to know is that a straight line will go flat. But it's going to be a flat line at its slope. So it was slope at part A was -13.3. So that means it's going to be a flat line going from time equals 3, from 0 to 3, at 13. So it's going to go out to here. Now this is a curvy line. We don't know how to get the slope of a curvy line, so we're going to skip that for now and go out to time equals 5. Time equals 5, though, is a lesser of a slope. It has a slope of 1.6, so it's up here. And it goes all the way out to 11 seconds. Now we get this line where it's a giant peak. This one is a positive slope, so it's going to be a positive line. So it goes all the way up to being a positive 9. So now it's going to instantly go to here. Now, plateaus don't naturally happen in the real world, but in physics we will say that it was going at a negative 1.6 meters per second, then instantaneously was going at a positive 9 meters per second without slowing down, speeding up, or doing anything. It's instantaneously. That obviously won't happen in real life. But now I'll go back into this curved line. Well, we know it's connected this line to this line, so all we have to do is connect it. Curves go to diagonals, and there's our diagonal straight line. I hope this was helpful, and I hope to see you again. Bye.